So today we're talking about the AWS Lambda client, ALC. I know it's a great name, right? Doing a demo of it. We're going to understand what the ALC is, why it's useful, and how to use it. Of course, my name is Paul Cruz. I am the engineering lead for Syngenta, doing a lot of DevOps, doing a lot of stuff like this, frameworks, support, all that kind of stuff. So let's kind of jump right into it. So what is the ALC? Well, the ALC is a library framework that we use exclusively with Lambdas, and we're focused primarily on the back end of the web application stack, right? So that's APIs, backend services, event-driven architecture, that kind of stuff. You can use Lambdas for a lot of other cool, amazing things, even serving up static websites. But we're not going to be focusing on that, and that's not what the ALC is useful for. It's mainly for the back end of your app. So why is it useful? Well, it's useful for a lot of reasons, right? Primarily, it's useful because it's a dry way of working with Lambdas. If for those of you who have worked with Lambdas extensively know that you're constantly doing the same things over and over again with Lambdas. And so this is meant to make some of those common use cases and implementations kind of be built in. That way you don't have to write code and share code or write new packages and share new packages. It's all built into the ALC and allows you the ability to just do it yourself, or do it with like a single line of code or configuration. It's also a lot more self-evident and declarative than standard ways of working with Lambdas. A lot of times for you to fully get a context of what a Lambda is doing, you have to see how it's configured, you have to see what's eventing it. The ALC is meant to make more of that upfront in the code base, so it's easier to work with and easier to understand like what you're actually doing and what you're editing or changing. And last but not least, it encourages what I like to call happy path programming. By that, it just means a way of coding that doesn't rely heavily on conditionals and try-catch exception blocks. The idea is that we want to validate most of our requests or most of our input before it goes into Lambda. So we have a very comprehensive validation library that makes it really easy to kind of validate your request, validate the event before you start working on it. And then we also have the ability for you as a developer to extend that validation library infinitely, as you can imagine, with any other custom, business logic kind of things you want to do. That way, the core crust of your Lambda is primarily focused on, the happy path with little if conditionals, little else, little try catch loops or try catch a block, and just working on it being straightforward all the way through. And last but not least, it is a very lightweight library. It is a lot more lightweight than a lot of the other wrappers you guys may Google. So there are ways of turning like Express Node apps into Lambdas, but it basically runs the Express app in the background, so it has to start the app and everything else. That's very, very heavy. And on top of that, it also slows down the Lambda. And if you guys know, you're paying for time, so that means it increases your cost. So this ALC is meant to just basically be a little bit better than that. So how do we use the ALC and what do we use it for? So we currently support 4 of the major use cases that we've seen across Lambda usage. That first one is API gateway and API request, which is probably the most classic use case of using a Lambda, right? Especially in our industry being ag, we're very seasonal and we have a lot of bursting, and you can't get more bursty than an API implementation. So this allows us to have that particular setup done automatically. We also see a lot of DynamoDB streams, which is really cool. We see a lot of S3 events, basically triggering Lambdas when you put things in buckets or change things in buckets. And then, of course, my favorite, SNS SQS, which is most of our event architecture is built on those two technologies in some way, shape, or form. Now, we do have more coming. So as we build out more use cases, we do plan on adding more things to ALC. But the idea of the ALC is to actually be useful, right? So if we have things in Kinesis stream, let's say that we do commonly, or that we want to be able to validate or whatever, we could add a Kinesis support to the ALC. But just having it to have it doesn't really, make any good use cases. So if we don't have good use cases, or if we have good use cases, we'll definitely add to the ALC and allow ours to extend its functionality. So let's talk about probably the easiest or the least likely thing that people use out of the 4 that we listed so far, and that's DynamoDB Streams, right? And the reason why I talked DynamoDB Streams is because it's pretty easy to cover, and it's our first thing we'll look at. So how do we use the ALC with DynamoDB Streams? So for those who don't know, maybe don't use it, DynamoDB is a database, right? And it's able to trigger a Lambda on any destructive operations. That's create, update, or delete. And that's really kind of cool. You can just basically do a lot of cool things with that implementation, basically venting off database operations. So the first thing we do is look at some code. Now, I've taken some code here just in screenshots because I don't want to type it out, but I do want to give you guys, a basic breakdown of how this actually works, how it actually looks. So the first thing we're doing is we're requiring or importing our DynamoDB event. This by itself, I feel like, is a very integral part of ALC by allowing you to dictate and declaratively state, hey, I'm expecting a DynamoDB event, right? And this means that any developer that comes into this project can look at this and go, oh, okay, this must be where we get the DynamoDB events. Instead of having to search for and figure out and look at the configuration of the Lambda to see what function is being triggered, you can make it really easy to say, nope, you can see it right here. This is what I'm expecting to get and what I'm expecting to see. The rest of this is just basically boilerplate, and it's around our event client, right? So we have a function that's going to trigger on an event. We have the event being passed in, right? And then we're passing it to our event client. And our event client is going to turn this, which is a DynamoDB raw event, as you can see, pretty intimidating, into this, right? A record client. Now, the record client is a much easier, straightforward way of working with DynamoDB events. We're not going to go through every property. Once again, we have documentation for all of that. But we are going to briefly talk about a few of the bigger ones. And the biggest one we have is the ability of turning DynamoDB JSON into regular JSON. So if those of you who don't know, haven't worked with DynamoDB before, JSON DynamoDB looks like this, or how every record looks, right? It basically has the keys and then a type in front of it. This makes working with DynamoDB difficult if you're working on the raw JSON, or excuse me, the raw DynamoDB JSON. It's kind of hard to work with. So what we've done is we've taken this JSON and automatically converted it for you into regular standard JSON that you're used to working with, that you would expect. So that way you don't have to like figure out the different types. You can just go straight into the key value that you're expecting. So that's the first thing we get out of the record. The other thing we get with this is the ability to tell DynamoDB when we want to run. The cool thing with DynamoDB Streams is that it always runs on all the events, but the bad thing about DynamoDB is that it always runs on all the events. So if you only wanted it to run on created items or updated items or deleted items, there's no way to configure that within DynamoDB. So we've done that for you. You can give us an array of events that you expect. It accepts create, update, or delete. And then this Lambda function, or this code rather, will only give you back records that match that event. So we figured out how to determine what event is being created versus what's being updated versus what's being deleted. And so what we're able to do is simply do that and put that into our code base, so you don't have to do that logic yourself. Very, very common. Now, what you could also do is actually raise an exception if you want that Lambda to actually throw an error if it finds a record that doesn't match your operations. This is kind of great for a use case if you're using DynamoDB as a pure transaction history. So let's say you never want records to be updated. Then you could say, hey, if I ever get an update or if I ever get anything that's not a create, then, go ahead and throw an error, and you can tie that into an APM solution or whatever you want to do and make it a lot easier for you as a developer to work with. By default, it's false, so it will just gracefully ignore any records that don't match the operations you've indicated. Now, additionally, we also have the ability to validate a schema of DynamoDB. So you can actually validate the record coming into DynamoDB and say, hey, this is the body I'm expecting to get. And you can define that either as a schema, as we have here, as an object literal of what we expect a schema to look like. Or if you're using OpenAPI, like most of us are in our projects, you can actually reference an OpenAPI schema through a string. Just say, hey, I'm expecting to get a schema path according to this OpenAPI YAML, and we will validate against that. Similarly, you're able to throw a validation error if you want the Lambda to stop execution, or if you want it to simply ignore it. Last but not least is the ability to extend your own custom middleware, and this is part about extensibility that we talked about before. The ability to basically write a before, I see on line 11 here, to write a before function that can do something to the record before it gets processed by the rest of your Lambda. So if you have additional logic that is not easily structurally determined, some other things you want to do, you can write a before method that will actually execute before, and you can share it across multiple Lambdas if you want to do it that way. So it works out really well and makes it very extensible. So that's basically how DynamoDB streams work and all the configurations you have, right? You have the ability to tell it what operations you want to run, make sure it's validated a proper schema, and then extend it even further by additional logic. And then after that, you get a much easier record, to work with, which is much easier to work with than the natural or the object literal that you get past when you're working with DynamoDB streams, in the natural or the raw way. So the next thing we'll look at is S3 events. S3 events are very similar to DynamoDB events as far as configuration. So we're not going to go over all the same things. You can do basically everything that you can do with a DynamoDB record, but we get some additional stuff. The first thing we get is the ability to get the object. So for those of you who have worked with S3 lambdas, S3 eventing lambdas, you know that you get a record that looks like this, right? It just doesn't really tell you. It tells you what the object was, but it doesn't actually like give the record in memory. So if you pass it the S3 event client, you pass it a get object true, it'll actually pull that file or pull that object from the S3 bucket, right, and pull it in memory. So you can actually operate on it. So if you're operating on an image or whatever, you can actually pull it in memory without you having to do it yourself. Normally, you get this key, you then have to call the AWS SDK, pull down the file, and then operate on it. We do that for you directly. You'll get a buffer object automatically if you go ahead and tell that true. Now, the other cool thing about that too is that if that object is JSON, we will actually convert it to a JSON object for you. So no longer will you have to then convert a buffer into a string into a JSON object. We'll do it for you automatically. And we also support that same operation with CSVs. So if you're getting CSVs, instead of getting, a buffer that you have to convert and pass to a library, we'll go ahead and give you an object literal that represents that CSV based on an array of objects. So it works out just well. And very similarly, you get the ability to run a before method. You get the same ability to look at that, but you can't have both, right? You can't have JSON and CSV. You only get the ability to run one at a time. So that'd be kind of weird if you had two in one file. The next part about that is that you can validate both CSVs and JSON objects against a OpenAPI YAML or a schema, up to you to decide. But either way, you can validate your requests, validate your input to make sure that it works. Now, this validation only occurs if you're using get object and it's using a JSON or a CSV. Obviously, we can't validate an image file or some other kind of shape file that you may be operating against. This is mainly just to kind of handle some of the more common use cases we see. So beyond that, we do have SNS and SQS events as well. This is really very, very straightforward. It's just like all the other ones. It has all the same functionality. Obviously, there's no file to pull, so there's no S3 get object, but you get the same idea. Most of us are passing around JSON strings as the body of our message for SQS and SNS. So you can validate that JSON string against a schema, and it will come back to you as a JSON object as well. It makes it a lot easier to work with. So that effectively covers, the primary three least use cases we have: DynamoDB, S3, and SNS SQS. The behemoth that we really want to talk about and spend the most of our time with, in the second half of this meeting with, is our ApiGateway API requests, right? So this is the idea of how do we use the ALC to basically work with API Gateway events. So there are two main ways that we can configure API Gateway to trigger Lambdas. The first way is the way that Amazon recommends, as you probably understand, is called the one Lambda per route, right? So what happens here is for every single route, like /grower is a separate Lambda versus /grower/ID is a separate Lambda. And as you can imagine, that is very cost benefiting to AWS to have that kind of system set up. But the other way that we recommend is one Lambda for the entire API. So you put all of your API into one Lambda, and then you go from there and you use an internal proxy instead of doing it one Lambda per route. Now, we 100% strongly recommend that you use the one Lambda per API, right? We definitely recommend this, and this is the only way the ALC currently supports. So bear with me for a minute as I get on the soapbox and I explain why this is the best case scenario for us as a team and why the ALC only supports this. First and foremost, you have better performance. As you guys know, Lambdas have cold starts, but after they've been invoked, they have a brief time where they're already warm, like a few seconds. So if you have all of your routes triggering off the same Lambda, you have a much higher chance of that Lambda being already warm, right? So if you're doing, a get request and a post request, that get request may be slow, but the conceding post request will be fast because the Lambda is already warm. In addition to that, you get better performance because Lambdas that are warm will cache a lot of the memory that they're already working, or cache a lot of the data they're already working with, which is great, which means it will operate faster. You'll do much more better things faster, which means that your overall cost will be less. In addition to that, Lambdas have the ability of what's called provisioning. So provisioning just means that you no longer have cold starts, but the Lambda is always running, right? And so you're getting billed for every hour that the Lambda is running. That's great if you have a very high throughput API, API service. And if you have one Lambda for the entire API, you can actually provision the entire API as opposed to having n times the cost for every endpoint you're provisioning. So this is a really big reason why we have this. You can actually set up a provision to be like only provision like 10 Lambdas, and then you'll only pay for those 10 Lambdas, month over month, which is like, $30 a month, something like that, not even, and then still get the benefit of the burstability of the high rate of burstability if you get a large, request load from your consumers or from your API users. So this is a big reason why we support this. And last but not least, a better developer experience. Conflicting routes are very hard to debug, and they do occur. An API gateway won't throw an error sometimes, so it's hard to figure out. And then you have less boilerplate when you're making a new endpoint. Instead of having to just go through and change a file here and then change a file in the configuration, it does it all for you. So let's go into our API gateway demo and let's talk about how all this kind of works. So I'm going to get out of this and I'm going to pull up instead actual code. We'll look at this. So we have, as I mentioned before, we have a large set of documentation that we can use. So we can have a full website we can work with, and we also have a full example set list like any of you guys can look at, can pull down. All the examples are located, where are they? Located in here. So we'll take a look. Set up. And you guys can kind of look at all these different types of examples, and you can kind of go through all the different ways of using the ALC. So let's talk about the first thing and most important thing is how do we route, right? Like how do we route internally if we're no longer letting the Lambda functions API gateway route per request? So we have a router, and our router has a few different ways of working. The first way is called directory routing, which means it's going to route based on the directory structure. The second way is called pattern routing, which will route based on a glob pattern. And the third way is our list router, which we don't recommend. It's a way of basically just listing off your routes and pointing to files. So the listing router was the first thing we'll cover because it's easiest to understand. It basically looks like an React app. So you'll have your router set up. This is your router. You tell it it's a list, right? And then you'll give it a set of routes, and those routes are going to look like something like this, right? You'll have your method, double colon, and then your path. And then you tell it what file to invoke. The one thing about this is that you have to match your method with your function name. So if we're going to call it get org, for example, we'll look at the org endpoint, and we can notice right here we have get function that does the same exact thing, right? So this get function basically triggers off this get function based on this file because we told it to. You can do the same thing with any other thing with route parameters inclusively, like we have our grower here. So look at our grower ID endpoint, same exact thing. We want to have our delete endpoint that talks to our delete function and very simply. So the list way is probably the most straightforward and easiest to understand, but it's not one we recommend primarily because number one, it doesn't really adhere to any standard. You allow yourself the ability to kind of have secret routes that developers can sneak in through PRs. And also you also don't get any of the benefit of like an organizational viewpoint of where code should go. But it does work, and it also requires additional boilerplate. Obviously, for every new endpoint you have to list off that endpoint and point it to a file. So not something we'd recommend. The one way that we do recommend, and probably the most straightforward for the ones that automatically route, is our directory routing. So directory routing is exactly what it sounds like. You are routing based on the directory structure. So as this example kind of shows, if you're doing /org as your route, right, you would do /org, the org.js file. So you basically, under the directory router, you pull up the router, you tell it where your files are, right? Like where your endpoint files are. And then you're able to say, okay, hey, if I'm hitting org, then it must be because I'm hitting the org endpoint, right? And so this will basically run this function for you, right? If you're doing anything with a path parameter, you basically wrap the file name in curly braces, and that will allow you to access that file directly like this, right? So it uses this dynamic file, or just, this route parameter to invoke this dynamic file. And we see that basically here, right? This example here. Same exact thing, able to then invoke this dynamic file. It's kind of following like some of the ways we used to do it back in the day when we had server-side requests. And then additionally, if you want to just hit /grower without the route parameter, we will default to index to any folder that has, doesn't have a path parameter to it. So in this case, /grower will hit the index file, and that will take over the /grower route. And the same thing, we get the .get.post, which basically indicates which method to run when. The cooler thing about this too is we get the same exact thing with our like super nested folders. So you can actually dynamically make a folder or directory dynamic as well to support that route parameter, right? So in this context, we have farm /farm ID. That's gonna basically work on this file here, and then we can then call in field with our field ID for this file or this endpoint, and this file will run on this endpoint, right? And so as you can basically see, the way you structure your controller handler directory directly affects the route's path you have. And this way, it's straightforward, it's easy to understand, it's very utilitarian, and it's self-evident, right? There's no list to maintain, nothing to worry about conflicting, because it's impossible to conflict because you'll have your route set up this way. Beyond just the directory mode, we have the pattern mode. So this is for if you're using more of like an MVVM style architecture, file product architecture, where you're having like, hey, I want to be able to have different things all inside the same directory. We get all that here kind of the same way. We can tell it a pattern. In this case, let's say we're using star.controller as our controller file. It will find this on the org. It will find the same exact thing with the dynamic files and the route parameters with curly braces around the file name for that. And this will follow the same way for this with the, with a folder that has a dynamic file name. So this will basically route itself the same exact way or similarly to directory, but it will follow your pattern saying, hey, I actually want only things that end in .controller.is to be my controller files. So these are the two main routing modes that we really do recommend, whether it be pattern or directory. They make it really easy to follow where your code can be and where your endpoint should be, and it makes it really easy to also share those kinds of patterns across multiple projects so people can jump around and find exactly where things are supposed to be. Now, the router and the way it routes is one thing that we wanted to change with the 2.0 of ALC, but the other thing we really wanted to get into was all the configurations that we have. So if we go back here, you guys may have noticed that though we have these particular, and I'll make my screen a little bit bigger, these particular functions that match the HTTP methods, we also have this requirements block that has something very similar, right? And so if you notice, what we have here is we have these requirements block that basically allow us to set validations around every request. And so we're going to cover that right now. So in the endpoint itself, we have a series of configurations which make it really easy for us to validate our request before it actually hits our code base. So first thing is simple, required headers. This makes complete sense. You're able to provide it with a list of headers. I'll scroll down as an example. And this can be one or many. It's an array of things. We also have the ability for available headers. This is a little bit scary, but this will only allow these headers to be passed in for available headers. I don't recommend this because it can actually cause problems for new requesters. As you guys know, a lot of HTTP clients out there will send their own custom headers. And then we have things like required query, which obviously is a type of the required query string. Available query, which is our available query string. A required path is required for any time you're using dynamic files. So if you have dynamic files like this, you have to have a required path with it so we can match your intention with the file structure. And then we have required body, which very much is similar to what we had before, which is the understanding of how your body is going to match against a open API YAML. And we have finally required auth. We'll talk about that in a second. Required auth we'll come back to. But we have a before method, an after method, and a data class. So let's talk about those. So where can I find those? So a before method allows us to basically write a function that will execute before the method is ran. And this is pretty cool for things like that you're doing consistently. So in this case, you notice in our case, we have like before grower exists. So we're trying to check to make sure that the grower exists before we try to get it, before we try to update it or delete it. And we can write one method here, right, that will basically allow us to copy and paste and use it again and again and again across multiple different endpoints without having to affect the actual logic of the endpoint. It'll actually run here by itself. And the validator in this case is actually going to operate and set errors whenever it matches something that doesn't, that doesn't work for us. So, oh, by setting an error, this error will then be dictated, will be, where is it? Where'd it go? Will be found during the before method execution, and then it won't actually run your method because it's found errors in the response. So that's a quick way and easy way. And the after method is another good way of looking at something and doing something before. If you have like permission systems that you want to filter out certain growers or certain data from certain users, you can do that here in your after method, once again, making it really easy for you to dictate and decide when you want to use that and extend the middleware without having to actually affect the middle, section of the code, which makes it a lot, dirtier and harder to follow and read. So this is meant to kind of break that up. The next part is what we call a data class. A data class is pretty cool. It will actually give you an instance of a particular class as opposed to an instance of, if I find an example. Yep, an instance of a class as opposed to an instance of the request object. So the request object is very similar to what you expect in any kind of like API framework, but instead of getting that, request.body.headers, etc., now you get an instance of your farm or whatever class you gave it, which once again reduces the amount of code you have to write and reduces the amount of stuff that you need to do in order to, actually operate on it. So as opposed to like doing stuff like this and then getting your farm and then exporting it or whatever, you're able to do something a little bit simpler and make it work a little bit easier. So that's how a data class kind of works. So all of these things are built into the endpoints, and they make it really easy for as you as a developer to kind of configure every endpoint to run like a module. But we do have some things that you can do to run as an entire, a global application. And that can be expressed, let me just give you 1 second, through our router. Where'd it go? There it is. So beyond the routing mode, beyond the base path, beyond our handler path and our schema, we have the ability to write a before all logic. So we can write a method that will run before every single request. This is great if you want to log every request, for example, to like a Mongo instance or DynamoDB for like, tracking or whatever. Same thing with after, if you want to be able to like validate requests or responses, against what your open API says. And then finally, last but not least, we have the ability to say on air. And on air will give you the ability to make any type of request on an error, meaning like an unhandled error. And you can do something clever here, like push it to an APM or just log it or, handle it however you want to handle it. So this way you get more customization. Now, these were in existence in the 1.0 version. We've also added a new one, which we called, and I'll bring another example. I'll bring it here as example configuration, what we call with auth. So with auth is pretty self-explanatory. It allows you to run an authentication method whenever you want to authenticate an endpoint, right? So you can say with auth, and then by saying with auth, you have the ability to say, okay, now whenever I use, and we'll lose the endpoint as an example, whenever I have required auth set to true, whenever it's set to true, I want this method, where'd it go? I want this method to run, right? Whatever method I give it, function I give it. This is great, right? It makes it really easy to tell and make endpoints private. No longer do you have to do it in before all and try to like guess the route. You can just simply indicate, hey, with auth, when I tell you this auth, go ahead and run this method whenever required auth is true. And that makes it really easy to work with and really easy to kind of repeat that logic. Now, the last thing I'll say, because we're running out of time, and before we do anything else, answer questions, is if you don't want to use any of the endpoint configurations, where were they again? Any of these guys, right? Or at least the ones that are structural. We now have the ability to validate your entire request against OpenAPI by using this one setting, auto validate true. So auto validate true will give you the ability to validate the entire request against OpenAPI without having to set required headers, available headers, required query, available query, etc. You basically indicate in your OpenAPI YAML, right, what the requirements are, right? If you have headers that are required, if you have, query strings that are required, if you have path parameters that are required, all of that, right, can be indicated within the OpenAPI YAML, and then we will, the ALC will automatically validate it for you. This way, it's less code for you to have to write, less requirements you have to write. The only requirements you would have to actually write are the things that you care about, like required auth, or before, or after, or data class, things that are logical to the operation of the code itself, not something structural like, hey, here's how my request should look like. So that's effectively it as far as the ALC and the way it handles API Gateway. As mentioned before, all of this is available currently online in our ALC documentation, alc.syngenta-digital.com. And then we also have a full list of examples that you can pull and look at any of these. All of these run locally, so you can actually pull it down, npm install, npm start, and like kind of play with it if you're curious to see how it works, and not have to worry about setting up an entire an entire project just to kind of play with it. In addition to that, we also have a list of all of our breaking changes from 1.0 to 2.0. So we listed off everything we've changed and how it kind of works and why we changed it. But if you don't want to do that, we have a simple bash script that you can run, and you can run this bash script, and then it will go through your project and do its best to try to, basically find and replace the things that we've changed. This way you don't have to do it yourself. Obviously, you want to make sure you're in a clean branch before you do that, so you don't mess up your entire project. But yeah, it's pretty cool in the way it works. As always, we're always looking for people to contribute. We do have an issues tab, so if you have any problems, please open an issue. Let us know so we can fix it ASAP. And where is it? And of course, if you have any other questions or concerns, reach out to the DevOps team or make an issue on the ALC. And thanks for you guys for your time.